6 months back, we launched SASVA 3.0, and since then, a lot of things have changed in the market. A lot of new platforms have come in, models have evolved, people are using in a different way. Uh, Now, today we have got team from SASVA, and we always wanted to know about SASVA's unique positioning about being deterministic platform. So let's hear from the team that in the context of all these changes, what is the meaning of this deterministic part of the platform and how it is helping?
Yeah, I think, as you said, there has been a big change in the industry about how new generation models have come up. They are capable of doing bigger things, they are capable of doing wider things. So things have changed with the evolution of MCP and what Anthropic was able to do in context to larger repository. It is changing the way AI was seen in software development. But then there are certain things which are still relevant when it comes to complex enterprise use cases. And I think for us, that is a sweet spot. This is what we have been focusing. So if you recall our version 1, 2, and now in our version 3, the third generation platform, we don't call it a generative platform. This is a deterministic and generative platform. And I know lots of analysts, they ask the questions about what is this deterministic all about. So maybe, today we will just focus on that aspect of why deterministic is important and how it is helping in a story where complex enterprise real world scenario, a common commodity platform, something that uses large scale models, are sometimes not enough to deliver results. And I think Pradeep will cover some of the technical aspect about what are we trying to do. But I'll simplify for the audience here. When you look at generative AI, no matter which technique you use, you will navigate through your data set. In our world, it is code. These are requirement documents. These are some of the feedback that comes from your market. When you bring all of them together, you send it to a model. The model can start guiding you on how to approach a problem. So many a time it goes into an iterative approach. It navigates through certain folders, your file, your system. It uses techniques like trace iter in coding world. It uses a lot of regular expression patterns to help you identify areas, and behind the scenes sometimes they are using embedding, they are using certain different techniques. But essentially it is a model that is driving everything, and that is why when you use Sonnet, when you use Opus from Anthropic, the results are extraordinary. So as people see cursor, you see windsurf and all, the results are extraordinary when there is Anthropic in the game. And your results started becoming like underwhelming when you use a smaller model. When you use GPT, for example, Gemini in some cases works really wonder. In many cases, we have seen it not matching to the quality that you get from Anthropic. So what is happening there? And that is a place where we have a huge role as a company. We realized that no matter how advanced a model can become, you need techniques to figure out how do you approach a problem, and you need techniques which can help you determine the best quality result. So I'll give an example, and I think Pradeep, you should explain, a very simple thing. There are two fundamental use cases no matter what you do in coding. On one side, the scoping and estimation is one of the biggest thing that is out there. When you look at a problem, you want to identify how do you scope it, what type of code changes are needed, where should you be making the code change. And on the other side, when you look at an architecture, you have to get it right. If you make a mistake in an architecture, the downstream work will start getting impacted. For these two fundamental use cases, we will take some time to explain you how they all will come together, when you see in a deterministic system. So to simplify, there are tools that are written that can look at certain dimensions and they can do one part of your job. Multiple tools come together to give you a better result. Now this is where agents are coming in. So there is one agent that use a technique to figure out what are the code blocks, what are the dependent modules that it has to look at when it is solving a problem. Now, in enterprise setup, you are not dealing with one repository. You have many repositories. There will be repositories for backend, front end. One requirement may affect all of it. And this is where things starts getting challenging. So in the context of agent, there is one agent that does one part of your job. There are other agents that takes the responsibility of doing it in a different way. In our world, there is an agent that uses models, there is an agent that uses machine learning techniques, and there are models that are designed to do one specific task when it comes to specific problem. They all collaborate and then they start solving a problem. And this is where generative agent has a very little role to play. While our deterministic agents that we have created, which uses tool, they don't use LLM, or they use LLM for a little bit of work, they take heavy load and they start delivering you quality result which matters in enterprise setup. And that is why in our world, when you have multiple repositories, when you have large scale repositories, the quality of results are far superior when you use this technique versus relying on model. So then Sonnet will give you better result, Opus will give you very good result, but when you use GPT, your results are very poor. In our world, whether you use GPT, use Sonnet, use our own models, because deterministic layer is designed to solve fundamental problems, our result quality will be almost similar when it comes to LLMs. Now, let's have Pradeep talk about some of these nuts and bolts that we have brought together. And that is why SASVA is relevant and more relevant today when models are becoming superior. I think this is a time that you need guardrails, and that is where our strategy is extremely powerful.
Yeah. So, see, basically, like Nitish, you mentioned that we have multiple agents. So there is one agent that is largely focused upon the generative science. So even though I say generative science, it is still looking at your code completely. It is going through various files. It may be also using lots of semantic and other techniques, but it is still largely generative, I would say, even with all of that science. So it does a job in certain limitations. It finds out whatever your intent is. Maybe you are fixing a defect, adding a feature. It finds out what are the candidate files. But then in many cases we have seen in enterprise setting, this is not enough. So we have done so many other types of agents, and I will give examples of a couple of them. So the first one that we have is where we take the code and we use lots of deterministic techniques, and some examples could be using the tools like John, even keyword searches like BM25, TF-IDF, recency, PR analysis, and so many other technologies using which we will find out features for each file. So we have lots of features, and then just like in Transformer, we have this attention mechanism, we have these self-attention heads where we are seeing that for a specific intent being adding a feature or fixing a defect, what and how these files are related to each other, what attention they are giving to each other. And based on that, we find out the candidate set. And we have seen amazing results using these technologies. And in this technology, we don't use LLM at all. It is completely deterministic. Another example being, we always talk about ontology, that it is the language of your business. The same thing needs to be explained in terms of code. Code is also your business domain, and you need to understand the language of your code. So what is the language of the code? Basically, we need to convert it into lots of domains, lots of modules, and these are not high-level modules that you can understand very easily, like front-end, payment, etc. It could be very smallish modules. So there could be thousands of modules, and then hierarchically we have found the next layer, and finally the modules which a human or architect can actually understand. Now these modules, each one has certain files, and they are related to each other in a complex relationship. So it is the ontology of that code that we need to understand. So when, again, the intent is coming and we are fixing a defect, adding a feature, we should be able to find out that, okay, if these files are affected, what are the semantic relationship? It's not a normal semantic relationship that we talk in terms of embedding. It is much more than that. What are the neighbors of that? And so using so many such techniques, we find out the candidate set. And then ultimately, all of this is fed to a reviewer agent, which has its own levers, and it finds out finally what is the actual candidate set. So if you have a 10,000 file repository, now you are looking at 100 files, and maybe ultimately candidate set is only 10 files, but then now suddenly you're looking at a very small repo in which any LLM, good enough LLM can do a very good job.
And I think one of the things that we need to understand here is what Pradeep was talking about. I think the techniques, this is the power of AI. If you feed right techniques in form of MCP tools, etc., you create a guardrail in a way that you want engine to sort of behave in a particular way. And that is why, if you all recall, I think our original notion about theme-based model fine-tuning, where we were looking at certain theme, like the strategy approach for a migration will be different than our strategy when it comes to defect fix. Where in defect fix, you have to identify which are the affected areas that you have to look at, what Pradeep just talked about. But when you're doing a large scale migration, the world is different. And again, if you are dealing with multiple repositories, you are dealing with very, very large complex repositories, I think these are the techniques that can give you speed, accuracy, and your AI will start behaving better. And do not forget, I mean, the third dimension we always talked about was the cost part. Today, when we run large models, for example, Opus is what, $75 per million token? And when you are dealing with large repositories where you are iteratively with multiple agents, you are doing a job, it becomes extremely crucial. And I think, one analogy that I always like to sort of bring in here is the aspect that we can't be 90% accurate when it comes to these factory work. If I get architecture diagram wrong, my work that I am relying on when it comes to architecture, they are going to get me a different result than what I am expecting out there. So again, coming back to the question about deterministic, I think in our world, it is more of a deterministic, very less of generative, which is why SASVA original foundation still stay relevant. Every time we talk to analysts, every time we talk to customers, we try and bring them to this dimension that in your world, you're not creating a greenfield application where a vibe coding can help you in a big way. Yes, these platform works wonder, but they have huge limitations when it comes to complex work.
Thanks for sharing, Nitish. Thanks for sharing, Pradeep. So I think few keywords here. One is for the enterprise use case, deterministic output is very, very critical. And the way SASVA is balancing science between generative and deterministic for ensuring the outcome are actually useful in the enterprise use cases is very, very well articulated, and thanks for sharing. Thank you.